Good day to everyone. Nice to have you all today attending our webinar in partnership with Jinko. My name is Natalia Chernyeva. I am commercial officer from Unisolar, and I will be your guide, let's say, on this webinar, and with introduction what we will do and what you will hear today from Jinko and from us. I hope you will join and will receive really interesting and new information for you. And before, just please check if visibility is okay, if you can see my slides presentation, if you can hear me well, and also my colleagues. So if something from the technical side goes wrong, so just put the message in the chat of the platform, and we will reply. We will clarify what is going on from each side, and we will make sure that you can hear and see as well. So let's start. Today we have a really good topic to discuss: how to increase the PV generation with Jinko modules, and also without practical cases, it won't be useful. So let's start. Here you can see the content. So we will start from the short Unisolar company introduction, just to let's say who we are and what we can provide to you. And then Jinko Solar introduction and technical side will start. Then we will have references with Jinko PV modules and price expectation. So be ready, ask the questions if any, and we will reply everything at the end of the presentation. Okay, then, so Unisolar, basically we are 15 years on the market since 2009 and are operating in Eastern Europe. So we provide, we have like a two business direction. One is turnkey PV station construction. Other one is distribution of the equipment, solar equipment. And our portfolio accounts over 300 megawatts already. And we, of course, we have the service center providing the warranty support and also operation and maintenance work. Basically, we are presented in the Eastern Europe, but we also have the offline offices, let's say, you can visit. So we have it in Ukraine, in Kiev, in Lithuania, in Kaunas, in Moldova, in Chisinau, and last year we opened company in Romania, in Bucharest. So what we provide is supply of equipment, right? Inverters, modules, having the direct contracts with manufacturers, and also not only supply but also service contracts, ensuring that everything goes right. If you have some warranty on warranty questions, and we can solve it easily and fast. Then of course we provide the design, construction, consulting, if anything regarding the technical due diligence of the project or of the released installed PV system, business plan, modeling, permission, licensing support and supervision. Of course, it's also the let's say after sales support, operation and maintenance. If you have any questions regarding our services and what we can do for you, how we can support you, so just please also you can contact me or my colleague Jonas. We will provide the contacts later. So let's start then with the Jinko introduction and very interesting part with the Jinko modules portfolio and also peculiarities, benefits, and advantages of the product, and actually how you can save the cost on BOS, the system. So I am happy to introduce Jean-Michel, who is the engineer of the technical department of Jinko and who can describe and tell everything in detail, and you can ask technical question to him. So if any, just print them into the chat, and we will reply. And also, if you can also write your questions in Lithuanian language, and our colleague Jonas can translate and provide to Jean-Michel. So definitely we will reply all of them. So Jean-Michel, just you can start. I will put my microphone and video off, and let's go.
Perfect. Thank you very much for the introduction, Natalia. Hello, good morning, everyone. My name is Jean-Michel de Groot. I'm made part of this technical service at Jinko. We're going to be talking a little bit about introduction about Jinko, who we are, and a little bit of our global performance. So as we already seeing, we already serve more than 200 gigawatts of modules all over the world. And we actually have more than 80 gigawatts of N-type production for module capacity. Another very important thing is we hand over 25 world records that we're going to be checking just in a few slides. And these records hand for module efficiency and cell efficiency. Okay, so if we go to the next slide, please. When we're talking about Jinko Solar, about being a vertical integrated factory or production, we're talking about that we are producing our own ingots, that we produce our own ingots, then we make our wafers to produce our cells, which we're going to be assembling them to produce our modules. So when you have the full control quality all over these different steps, you're going to be able to produce top quality modules. That's why a little bit we are on the top 5 manufacturers right now. If we go to the next slide, we're going to be able to see all the different awards and certificates we currently have offered for different companies such as TÜV, Rheinland, or PVL, which is an American company that stand for our reliability for our models. Okay, if we can go to the next slide. When we are talking about these 25 world records, we're talking about, as I was saying, our cell production and cell efficiency and module efficiency. In this curve that we can see, our numbers that are placed in the top are mean for cell production, and on the lower part are for module efficiency. I would like to highlight our first world record, which is going to be our efficiency on over N-type polycrystalline cells, which is in DU's technology we are not producing right now because we are only focused on monocrystalline cells. But already in 2017, we were already producing our N-type modules. Okay, so that's something I wanted to highlight. If we go to the next slide, please. Our current portfolio, we still have P-type PERC production and also N-type production. So as we can see, we have our Tiger Pro and our Tiger Neo. We still have over less than 20% of our production is P-type, which is going to be PERC, and more than 80% is going to be N-type. So we're still producing P-type due to different old contracts we have in the market, and we have to continue serving models, but also expect a change that we are only going to go for the N-type. Okay, we have a little bit difference all over the cell size. Okay, we have the square ones, which is going to be 182 millimeters, by 182 millimeters, and then we have our rectangular cells, micro-rectangular, rectangular. We'll be talking about all of these in a few slides. We can go to the next one. Different scenarios and applications for our models. As we can see, we have designed different scenarios for our models. These are going to be utility ones. These are going to take into mind 78 cells, 72 and also 66 cells. These models are going to be meant for energy production, in higher rates, as utility fields. We also have the Tiger Neo 54 cells, which is going to be for residential, and also our CNI models, which is going to be our Tiger Neo 60 for industry. Okay, if we go to the next slide, please. We're going to be talking a little bit about our development trend all over our models. Jinko Solar is a very conservative company. This means we were performing and we were developing our P-type models, which are PERC, and we were seeing that the curve for efficiency were attaining to a limit that we weren't doing that many breakthrough over the efficiency. So that's why in 2017, we start thinking and believing that with our N-type models, we were going to be able to change this efficiency level that we were having, because our R&D the department was seeing that we could have some space for augmenting this efficiency. That's why we switch from our PERC P-type cells to our N-type cells. This was PRET, PERT with a T, and then we switch to our TOPCon. More or less, what we are seeing in this slide is the different steps we have been making in our TOPCon models. In 2023, we have the selective emitters, and for this year, we're going to go for the fully passivated TOPCon, and we expect for 2026 or 2027 a TOPCon tandem cell. This means that we're going to be mixing different technologies such as perovskite components in order to have these efficiency limits. Okay, if we go to the next slide, please. Where are we located right now? As I was saying, we switched from our PERC technology to our N-type. We did a first generation, which was the PERT, and then we are currently right now at the TOPCon technology. Of course, our R&D department is making different studies, and we haven't forget about our different technologies we have, such as heterojunction with contact, different things. But right now, for an instance, our focus is going to be in our TOPCon technology. Okay, if we go to the next slide, we're going to be seeing a little bit exactly and where we are. Okay. This is what I was talking about later. If we can go to the next slide 1 second, we're going to be able to see the breakthrough we made, because in 2017 we were producing also our PERC models, but we saw that we have a higher pace. The slope of the PERC was attaining already a limit where it was going to be it was going to be with no enough changes. So that's why we select our N-type models because we were seeing that we were having a huge increase. There was a time that a company was producing models where that's why everyone in the industry was switching to PERC, and until we managed to make this breakthrough and to have mass production efficiency models that get over this 25% of efficiency. And that's why a little bit the trend of the market is now we change it to N-type. That's why you are going to be seeing all the different companies who are going to switch to this N-type production. Okay, we go now to the next slide, please. We're going to be talking about a little bit of our portfolio or our different models we are having. For an instance, we're talking about a C12 size of the cells. This means that are going to be 182 millimeters, 4.3 times 210. This means an increase all over the length of the model. But just take into account, we're going to be talking a little bit about the nomenclature of our models. As you can see, GKM stands for Jinko Solar. The small little X we can see in the models stand for the power. We're going to be having 66, 72, 54. It's going to stand for the number of cells we're going to have in our model. Remember, all of these cells are half cut. Okay. HLM4 are going to stand for internomenclature, but just take into account if we have a V, is going to stand for monofacial, or if we have BDV, it's going to stand for bifacial models. Okay. Here we have our new 66 cells models. These are C12 size models, which are going to be have more area than the other ones we have that are the 182 or square or micro rectangular cells. We also have our bifacial all black model, which we're going to be having a little bit of more information in the next slide. If we can next, please. Okay, thank you. We can already see the huge elevated aesthetics that we have. We also increase the thickness of our glass to have better mechanical performance, mechanical loads, and fire and hail resistance. Okay. On top of this, we have a 25-year warranty for reliability. This means our premium products, which is the Tiger Neo double glass, all black, and all black also, is going to be with a product warranty for 25 years. Power warranty for all our models is for 30 years, as we will be checking in the next slides. We can go to the next slides. We're going to be talking about our current production. A little bit more of the same. We have 78 models, 72 models, and 60 models. All of these models can be used for the 78 and 72 models are used for utility projects, and the 60 are more focused to the CNI production. Okay, a little bit of information and something that I would like to highlight is that in all our models, you're going to be finding the same length or width of the model, which is going to be 1,134 millimeters. We made this to be able to switch in case that the model is going to be with any kind of issue, and you're going to be able to switch our models with another one who is going to be electrically compatible or with another of our models without having to change the whole structure of your racking system, which allows us to have modularity between our models. Okay, if we go to the next slide, please. In this part, we're going to be looking our rectangular cells. We're going to be 182 times 186.8 millimeters, and all these three models that we are seeing right now are focused on residential ones. We have our monofacial all black model, which is our premium model, and also the bifacial dual glass model. Okay. Again, the same length for the 1,134 millimeters. Go to the next slide, please. We're going to be talking a little bit about the power and optimized performance. This is going to be for our coefficients, our degradation values. So if you can see on the different graph, we're seeing that for the first year about using N-type models, okay, we're going to have a degradation less than 1%, and on the following years, on the linear degradation, we're going to have a 0.4%. This means that into our power output, if we're not complying to our 87.4% of our power output after 30 years, you're going to be able to claim that model that wasn't performing, but I strongly believe that it will be. If we can go to the next slide. When we are talking about bifacial factor, the way of our structure, of our cell structure is made, instead of P-type, we're going for the N-type, we are going to be having more values, a higher value all over the bifacial factor. This means we're going to be able to gain, thanks to the albedo effect, we're going to be able to gain more energy through the rear part of the cell, thanks for the albedo effect, which is going to be, of course, depending on the rear irradiance of the site and also the ground reflectivity. The values should be aligned between 5-6% up to a 12-13%. Remember, this is going to impact and depend on the rear irradiance and ground reflectivity. Go to the next slide, please. When we're talking about optimized temperature coefficients, we're talking about that our models are going to be able to handle better the temperatures and produce more energy within the same cell temperature. This means, for example, for a P-type model, if we are working on 55 cell temperature, we're going to be producing less energy or less power than with a TOPCon model. It's more about a 2% between these two models. So, of course, one model is not affecting that much, but in the end, if we have a utility or a different string, this 2% is going to be affecting slowly and better. If we go to the next slide. When we are talking about better low light performance, our models are going to be producing more energy under lower light irradiance. This means that maybe around the 400 watts per meter square, we're going to be having more energy production than with a P-type model. This goes to the way that the structure of the cell is done. With our P-type cells, we're not able to have these minority carriers. We're not going to be able to restrain that as well, our minority carriers in the cells. So we're going to be having a more restricted, more resistance in our cells instead of our N-type cells. Okay, more or less, we're going to be gaining 1 hour into the morning and 1 hour into the evening. If we go to the next slide. What about BOS system, BOS, and what about the LCOE? When we're going to choose a PV module for a project, we have to also check on the balance of systems, which will stand for BOS, and also the levelized cost of electricity, which is going to be the LCOE. Balance of system is going to take into account is going to encompass all the different systems we have in our PV site without taking into account the modules. This means it's going to be for the wiring, for the racking system, and all the different elements we have into our PV plant without taking again account our PV modules. The LCOE is going to be a metric that we're going to be using for compare the energy production that the different source of energy we're going to be producing. Okay, if we go to the next slide, we're going to be able to see our formula in a way that we're going to be summing the cost over the lifetime of our PV site and over the sum of the electricity that we're going to be producing. So if what are going to be affecting our models, as we can see on the right side of the slide, we're going to be also checking the installation parts, the BOS, the system lifetime, and the system efficiency. Our models are going to affect in each of these parts in different ways. If we go to the next slide, please. Why does our Jinko models then make lower BOS? I've summed up different points that we can see over here, and they are going to be talking about module efficiency, the size and weight, durability, compatibility, and ease of installation. So all these different steps that we can cite, that we can talk about. For example, the module efficiency. If we have the same modules with higher efficiency, with our models, we're talking about the 72 module and the 66. Our 66 modules are with higher area of cell, which are going to affect always to the higher energy production. If we have slowly taken with our R&D department better efficiencies, we're going to be gaining more energy than our other models. For the module size and weight, if we are making more reliable our models, we're going to be able to decrease the price in our racking solution and gain more space. Our durability and lifespan, if we have, for example, we pass in TÜV our 3 reliability test, which means we're going to be passing 3 times the ESC, and we have approved this. We have all our certificates. We are going to be talking about this lifespan. It means that our models are going to be more reliable. For the compatibility and ease of installation, we're going to be talking about different ways that our models are going to be installed, and in which way we're going to be able to change our models or decrease our cost of installation without following racking systems who are going to be normalized. With advanced technologies, meaning that if we are on top of the technology, meaning that we are always changing our models, our technology to be always on top of the market. Warranties and long-term performance, we can have some examples about how this the difference we can find our P-type and N-type as we have less degradation all over the years, and some innovative designs for always we are trying to look for them in order to make this cost reduce. We go to the next slide, we're going to be able to see some key points about the installation wisely, avoid shadowing, avoid different parts that can decrease the energy of our models or our site. Choose the most efficient design for your installation. This is going to be always going through the calculation of the number of models we can have per string. If we go for models that have a lower VOC, we're going to be able to put more models per string. That's an example. Always look for standardization and modularity for your system. If we have always use one model who is going to be standardized, the way we're going to be assembling it is going to be less cost than if we try to go for different ways of installation of these models or the racking system that we are will have to pay for different testing or different things to be able to have this permission or this approval letter. Always negotiate effectively with your suppliers. If we go to distributors, we're going to be always have these chains because they are always going to be optimizing the logistic chain. Okay. Always look for the best technology in the market. It's not the same to have a company that has been working through N-type models for already, we're talking about more 7 years, than a company that is going to change suddenly their production, which is going to take slowly different steps into this process, and always conduct a correct evaluation of the lifetime of the installation. We're going to be presenting a small, if we go to the next slide, we're going to be able to see an example for a PV site in China between two of our models for a utility project. On the left part, we have our 72 cell model, and on the right part, we have our new 66 cell model. What's going to be the biggest difference? Of course, the area of the cell. We're talking about 182.3 millimeters is our micro rectangular cells, and our 182.3 times 210 millimeters, which is going to be our rectangular cell. This means that we're going to be more area per cell, which is going to be a difference in the number of watts that we're going to be having in our model. We're talking about that we have 30 watts of difference between these two models, but and also a difference in weight. We're going about 1.4 kilograms and also 104 millimeters more of length. Okay. With the same number of models, same degradation, because our cells, the only thing is going to change is the area of the cells. The sames are all the same, okay, between all our models when we are talking about the N-type models. If we go to the next slide, we're going to be able to see the results that we managed to have. And of course, if we go for a lower VOC, we're going to be able to put more models per string, which is going to end that we will have to install less strings. This is going to affect directly to the number of models, to the number of racking systems that we have to use in our system. And it's going to affect, of course, on the BOS, and which will be finalizing into lower results or lower LCOE cost. And we can go to the next slide. And I will leave the stage to my colleague.
Thanks a lot, Jean-Michel, for your presentation, and I'm glad to introduce my colleague, Jonas Stankevičius. He is the country manager for Lithuania. So, Jonas, we're ready to start. Let's go.
Yes. Hello, everyone. My name is Jonas, as Natalia said, I'm representing Jinko Solar in Lithuania. Well, Jinko is our long-term partner since 2014, and we have direct sales and service agreements with Jinko. Well, please, next slide. There's a couple projects we have made with Jinko. This is a 5 megawatt PV system. Was launched in 2018. The customer wanted to install 270 polycrystal models that were popular at the time, but we convinced him to go with a growing better technology like monocrystal, 285 watts, with first year degradation of 2.5% and 0.7% annually for 25 years. And with that technology, customer received better production from 2019 till 2021. The data from 2022 till 2023 is not relevant, as there is the limitation of the production to the grid. Well, the next slide, as you see, is 2020-2022 commissioning project with the mono models and planned production in Ukraine and Moldova. And you see that the production is better than fact. Thought there a month when plan didn't match fact due to the weather conditions that may differ to plus minus 5%. Okay, and there we go with the project, which is in Lithuania. That is not commissioned yet, but will be soon. And this with the Jinko beneficial N-type monocrystal modules. This built last year and will be finished recently. Next slide. And due to the technology improvement, yield production improves, but also there is one of the facts we want to share. You see the flash report screen for the models of Lithuanian project. Nominal power is 560 watts. Tolerance is plus old plus 3%. Therefore, you get up to 16.8 watt more as flash report measures, and receiving 1-2 years extra until PV models degradation gets to the normal power. That's the main point. And the next one, please. Well, for many years, we have seen that Jinko does its best by providing high quality products, services, and doing more than expect, so staying on one of the best on the market. Thank you.
Thanks a lot, Jonas. And now let's go to our very expected point with price. So I am glad to introduce Yevgen Prydatko, who is the business development and sales manager of Jinko, also for Lithuanian market. And hello, Yevgen. So let's start.
Yeah, okay, so I will cover, as Natalia already said, I'm a business development and sales manager, Jinko Solar, responsible among others for Baltic states, Lithuania, Latvia, and Estonia. And yeah, I will cover the price topic in this webinar. From my point, it is not a lot of slides, but I hope it will be also interesting. So let's start. Yeah, first of all, a lot of you are asking questions about the price, about the trends, what will happen, and so on. And here we need to understand where the prices are coming from, where they're jumping from, and how producers are deciding what price to offer, and so on. it is a lot of factors which are impacting price. Yeah, and I will describe the main groups of these factors, just to bring understanding how it works. First of all, the first group, it is the raw material group, covers raw silicon price, wafer price, and cell price. As you probably remember from the slide which was explained by Jean-Michel, we are vertically integrated company, so we are producing wafers and cells on our production facilities. So for us, most important factor which impacts the final price for you, I mean the price of the modules on the local market, is raw silicon price. A second group of factors is another materials like non-ferrous metals price. As you probably know, we are using aluminum for frames, we are using silver for soldering, we are using copper for cables, and so on. And of course, this materials price impacting the price of the final product on the local market. It is also plastic materials prices. You know, we are using plastic backsheet or lamination layer, and also the glass price. Yeah, probably you remember the times when it was I think 2-3 years ago, when it was the shortage of glass on the Chinese market. And as you know, the majority of our production facilities in terms of annual capacity are located in China, and it was times when it was a glass shortage on the market, and of course it impacted the final price of the product. Yeah, next group or next factors are logistics costs. Of course, for our products, especially for the modules, in this group, ocean freight is very important, because you know now the situation in the Red Sea, and this situation impacts the price for container costs significantly and heavily, and of course it impacts as a result the price of the modules on the local market. And next group of factors is let's call it financial factors. First of all, it's exchange rate, because between Chinese yuan, between USD and euro. You know, when we are producing in China, of course, we are buying a lot of materials in Chinese yuans, and then some of them we are buying in dollars, and finally we as a wholesaler or our partners, Unisolar, they are selling the modules in euros. So of course the changes, the fluctuations between these three currencies are impacting the final price. Of course, on some markets, it can appear some market limitations. As for example, not sure if you remember, a couple of years ago, it was limitations in terms of importing Chinese products to European Union. And that's why this limitation impacted the price as well. Now it's cancelled already. We are supplying from our factories in China, but still it can happen. And also very important topic is demand. Yeah, as that's the standard factor. As higher demand is, as higher the prices are. I think you know this. And from all these factors, I would like to show a bit deeply two of them. First is raw silicon price, and second, logistics costs. Because from my point of view, these two factors are impacting most heavy the final price for you. For example, on the left diagram, you can see fluctuations on the stock exchange of raw silicon price. And as you can see from the beginning of this year, week 2, week 3, week 4 this year, you can see the price for raw silicon N-type grew up. Yeah, from 64 yens to 70, 71, depends on which source we are using. Yeah, and of course, as the raw silicon is the raw material for the core of the module for solar cell, it of course impacts the price of the modules. To be honest, the situation happened in third and fourth quarters of the last year. It was something exceptional. For all my experience, in all my experience, I never saw such price drop. Yeah, which happened in, which started in June, probably late May last year, and kept till December last year. But as for now, January, February this year, you can see it is already growth of raw material price, and it is some growth in term of final price for the modules on the local markets. Yeah. Second diagram shows the change, the fluctuation of the price for logistics cost from China to Europe. Of course, it depends on the port of arrival, if it's Rotterdam, or if it's Klaipėda, or if it's Tallinn. It's different EU costs, but in general, the situation in the Red Sea impacted all shipping lines and all directions. I mean, all directions in Europe. Of course, Rotterdam is still a bit cheaper compared to smaller ports, but the trend is clear here. Yeah, you can see price for delivering standard 40-feet container from China to Europe grew up significantly, and it impacts the final price of the modules. Below the slide, you can see some quotes given by experts to PV Magazine or to S&P Global Commodity Insights in February this year. So from these two quotes, you can probably understand what is waiting for us next months or next weeks or next quarters. That's how I see the situation as well. So producers of the modules, producers of raw material silicon, of raw silicon, are not able to work with losses. You know, it will impact the business, and it can do a result as a bankruptcy of producers. That's why when you are seeing low prices, and if you understanding that producers are working or are producing on the limit of profitability, it is not really good situation for all market players, not only for producers, but also for end users of the modules. In my experience, I saw a couple of big producers which bankrupted. Yeah, so and it impacts all players. For example, nobody cares about warranties for the modules if producer is bankrupted, and in this situation, the end user is alone and unable to solve issues if such kind of issues are happening. So it's important to keep profitability not only on the level of raw material production, but also on the level of modules production and on the level of installers who are installing modules. It is no other way in this case. Yeah, so from these two quotes, I think and what I see will happen. First of all, it will be turbulence, yeah, because a lot of production facilities are concentrated in hands of a couple of big producers. It means that it will be hard to compete for small producers, and probably you will see some small companies bankrupted or bought by big producers. You need to keep it in mind, and you need to work with trusted producers and trusted companies. Yeah. And another factor which I wanted to mention, I believe all of you already saw the last Tier 1 report from Bloomberg New Energy Finance. And if you saw it, now the last report and the list of companies in the last report is much shorter compared to what they published previously. Yeah, so they cut some producers from the Tier 1 rating, and it will also impact the market. So from my point of view, in Europe now, high demand, the logistics costs from China are higher compared to what it was 3-4 months ago. The raw material price shows the trend to grow up, and all these factors are showing that the price, conservative scenario, the price will be at least stable, but from my point of view, price will be growing step by step, probably not as significantly, but still in short-term forecasts. And in long-term forecasts, for me, it is hard to say what will be happening in Q4 and next year. But my suggestion for you, if you are planning projects, if you are planning PV stations, to make it as early as possible. I mean, you need to place orders. You need to be sure you will have products on time, and to do this, to have this, you need to plan in advance. From my point of view, better at least 3-4 months, but if you can plan your projects 1, 2, 3 or more quarters in advance, it's even better. So that's my vision of situation. And if you have questions, I will be more than happy to answer if I can. Thank you very much.
Thanks a lot, Yevgen. Thanks a lot for the presentation, for your expectation. Just my question from my side. So as we saw availability of the PV modules on the market last year, so this year will be not the same. Let's say you need to book in advance, or like if we speak about some bigger projects, right? Or to find the distributors with availability. So there are no so much stock as it was last year, right?
Okay. Yeah, I'm here. Regarding the situation with availability and free capacity production volumes, I can say following. First of all, yes, you're right. The last year was absolutely different from what I ever saw in my life. And last couple of months of the last year showed us that it is a lot of modules in Europe, because the situation in Europe was not the best in terms of PV installations, and a lot of producers faced full warehouses of the products. But from my point of view, all distributors and all end users were thinking that, okay, it will be the trend next at least a couple of quarters or probably next years, that we will buy everything we want in a short period of time, like we order today and we can get modules tomorrow. But the situation changed, at least for us, changed significantly starting end of December, beginning of January. As for now, it is not a lot of products in our European warehouses. And even more, the containers and modules which are on the vessels now and going to Europe, majority of these products are also sold out. And it is the same situation with our production facilities. So that's why I am suggesting you to not wait and to place orders right now if you want to install or commission your station in June, July, August this year, because the situation with availability is not the best for the end users and for the buyers. It is really lack of products for now, and if you want to get products in short period of time, be ready to pay higher price compared if to place long-term order. So that's the situation.
Yeah, thank you, Yevgen. Thanks a lot. And we managed to make some stories post in our social media to ask our customers regarding the question to the speakers before the webinar. So we have got some questions, and I'm ready now to ask. So Jean-Michel, I guess the question is for you. What are the materials and technologies used in the production of Jinko solar panels to ensure their durability and efficiency?
It is going to be always, we're going to be talking always about the doping part, at least for our N-type cells, because we're using monocrystalline cells made of silicon, etc. And how we're going to be able to rely on our materials is the question, right?
What materials are used in production?
It's going to be depending, but we have newer factories that are mainly use only machines that are going to be producing these cells, and also for the installation or assembly of the cells. And we have a little bit of everything. We have more than 14 factories all scattered all over the world. So, but yes, the materials are going to be, the machinery is going to be one part, and materials is going to be for the silicon and also for the silicon that we're going to be using. We basically buy the silicon and then we produce our ingots. And then with the follow-up of all the process, we're going to be able to assemble our modules. And for the reliability of all the different materials we have, it's going to be always checked by our quality team that is on factory. And of course, we are always testing our own models ourselves. We are in contact with all the different laboratories to check ourselves our own models. We made it in the labs in China, we made it in the labs in America, in the labs in Europe, a little bit of everything.
Thank you, and I think it's like in prolongation to continue this question.
I'm not hearing you, Natalia. Apologize.
Sorry. Now it's in continuation of the first question. What is the expected lifespan of Jinko solar panels? Are there studies you can share or data on their durability in different climates?
So yes, we have tested our models in different climates. I currently don't have access to be able to show them, but yes, we have been testing our own models in China, in South Arabia, in different ways to check also about our thermal coefficients, how they were going to behave in different conditions, in different sites. And yes, we have our own plans to go in this way, where we are able to check, and also we have been made different reports over the different sites where we can see where we install our own models, B-type and N-type, to see the difference between them. And of course, that's why we are reliable, and that's why we are able to make these statements. We have all of these and the certificates. So if anyone wants to check them, please just send a mail, and it will be kind to send it.
Thank you. And also one question, technical question: what are the safety measures for installation and operation of panels, and how is protection against fire, overheating, and other potential hazards ensured?
So we have all of these state in our installation manual. I recommend to check it. But for example, fire hazard is going to be always covered by the extended part of the flame. This is going to be handled by the fire resistance test we have. There are two different tests. One is for the flame spread, and the other one is for the material and how it's going to be handled. This is for the fire hazard, and of course we have to test our own models just to be able to check this. And for the safety for the electrical shock and all of these, we recommend, and it's obligatory by the ESC, we have to ground our models always to the structure, which is going to be grounded into the soil. So yes, we have all of these stated in our installation manual, and if you follow correctly the installation methods and our recommendation, there shouldn't be any issue with our models.
Thanks a lot. Thanks for your answer. And also one more question, I think we can answer it. So what additional components such as inverters or mounting systems are recommended for use with Jinko solar panels, all for optimal performance? So actually usually it's an individual project, rather like it's a residential system or commercial or utility one. So we need to to optimize the technical offer to make it feasible according to the requirements of the customer. So we have to choose the right module and the right inverter in configuration. So rather to optimize the cost on BOS systems, so to decrease LCOE. So basically, you cannot, for example, use like 10 kV inverters into utility scale systems. So you will, depending on the size, use like string inverters, like high voltage or central inverters, but always depends on the size of the project, on the location, on the other factors impacting the performance. So actually, like you cannot go like, okay, use such inverters with Jinko or do not use. So actually, we can think of the needs of the customer, right? And what he sees like in the warranty, in the quality, in the performance, in the lifespan. So taking all of the inputs, we can make the combination that will ensure the durability and minimize the end, the capex, the opex of the system, and also the end price, whatever it's economy, right, for self-consumption, or you sell energy into the grid. So actually it will be going like this. So let's have your need, what to have in the end, like what is the questions from the customer, what you want to achieve, and for sure we will provide different combination configuration and show you that, like, for example, with this PV module and inverter you will receive such result, and with another, and you will choose. So based on the on the different factors like this. Thanks a lot. It was like interesting question. And one more question, I think. So it was the what challenges have been solved, or what results have been achieved through the use of these modules in specific projects? I think I can answer this question as well. So as you saw, my colleague Jonas showed you the first project case we have done in we supplied PV modules in 2017, and this PV station was commissioned into 5 mega PV station in Ukraine was commissioned in 2018. So as he told, customer wanted to go with like regular for that time polycrystalline modules 270, and we just combined different configurations. So we showed the scenarios, for example, with these modules, with mono modules, and later on, because it was this stage, first stage of the project, and next one stage, second, it was 10 mega. So for the first stage, we convinced him to go with the monocrystalline modules 285. So why? Because even this technology was higher in the price, if I am not wrong, like for 2 cents. And but in overall, so customer in the end, in the result, had economy on the mounting rack, on the structures, on the cables, using the more powerful modules, and also he got more yield in production. So basically he returned the initial like investment for the higher price technology, and this investment, this difference was paid back in 2 years. Like it was, and then he received more yield than for the next years than it was with the technology polysilicon. So basically, he received optimized LCOE, and he was able to receive more, earn more money for the energy he produced. And then into the second stage, we convinced him to go with mono PERC 320 watts, and also showing the cases, like comparing between, because it's very important to show like every side from the production, from the like all the system, because anyway you have somewhere you have economy on the on the cabling, but yeah, you're paying for the more costly technology, but in the end you receive more production economy, and you receive more money. Of course, it was like feed-in tariff project, but nevertheless he received, he paid back the project, and it was really nice case to learn and to show to other customers. So how it works and how we can compare different technologies, even if some technology is more expensive for the moment. We are almost at the end of our webinar. So if there are more questions, I here received one question in the chat. We use bypass diodes in all our modules. This is nearly a standard in the industry, as it helps to prevent losses. It was a reply, right?
Yes, indeed.
Okay, yeah. So basically, if there are more questions, you can ask me, Jonas, and also colleagues, our colleagues from Jinko, our partners, and we will reply each of the question. And also, if you have a question regarding the PV modules you want to order, so you can ask Jonas regarding the quote and availability. And I hope that today's webinar was interesting and valuable for you. And thanks a lot for coming, for attending. And we will also share the recording with you. And thanks a lot. Wish you a really good PV production with your customers, or if it's your project, and as short paybacks as possible. So thanks a lot to my colleagues and partners for this webinar, and hope we can do more for you. Just ask. Thank you. Have a really good week and day.
Thank you.
Thank you, everyone.
Thank you very much.
You.
Have a nice
And
day. Thank you.
Have a nice day. Yeah.
Have a nice day, everyone. Bye.